My name is John Wilker. I'm a professor of chemistry and materials engineering at Purdue University. So what we've been doing is making new cements, and in society we're always looking for higher performance materials, and we thought one interesting place to look would be in biology. So oysters make cements to bind themselves together and build reef structures, and cements are, in lots and lots of structures, one of the more common man-made materials, and so we're looking for new ideas on how to make higher performance cements. So concrete is the material you might see as entire structures, beams, buildings. Cement is one of the components within concrete that holds it all together. So for this new cement, what we did is we made some synthetic polymers that are somewhat like the proteins that the animals are making. And in particular, the animals have these chemical phosphate groups, and we put those into the polymers, and then we combine them with inorganics like calcium carbonate. And we tuned a lot of parameters in terms of ratios and of the components and such. And then we would test the mechanical properties of the materials that resulted. And under the best of circumstances, we could make some cements that were very adhesive and also quite strong in compressive strength. So what we did is we took a very common household concrete that you can buy at a local hardware store that you just basically mix with water, but instead of just mixing with the water, we added in the polymer that we developed after studying what the oysters are making, and it enhanced some of the mechanical properties of this concrete. So the compressive force of the material basically doubled, and the actual adhesion sticking substrates together went up by about tenfold. So when we make new cements, one of the ways we want to test it is we'll make them into little cubes, and then we'll put them into an instrument and basically squish them down until the point that they shatter, and that tells you what your compressive force is. And so you can see, for instance, this one has some polymer in it and this one does not. So we're testing all different compositions and sort of charting out the mechanical properties as we make changes to the materials. So this is an example where we took the new biomimetic cement that we made, bonded two bricks together, and here we are, they're stuck. Looking to the future, there's a lot of things we want to do in developing new cements like this. For one is we want to further enhance some of the mechanical properties. So water resistance is something we need to work on. Enhanced compressive strength and adhesion are still things we're looking at. What we also want to do is we want to sort of pair with people who are much more experts in this field than we are to learn what are sort of some of the most pressing problems that we could apply new materials like this to, and develop collaborations that way. I mean, in general, whenever you see concrete or whenever you see cement, there's plenty of times when you want higher performance, right? So you want things to not degrade and not crumble, or a big thing in this field now is trying to make cements that are lower carbon output, because you need tons of heat to make the components and put them together. And then, we always hear about, buildings collapsing and bridges coming down. So basically, if we could have higher performance materials in this space, there's endless applications. Cement to each other, and then if you have 50 miles of this, when the storm surge comes in, like from a hurricane, it dissipates the energy. And this is one animal, this is another animal, this is another one, another one. They're cementing together. We're trying to carry.
Yeah.
But it is an issue. It's another example where you're just all these two tubes together.
Yes, you showed me that. What was that whole
So this y-axis here is measuring the force that it takes to pull substrates apart, and then it analyzes it over the amount of distance that it's actually being pulled apart from each other. So it's done. So that's one adhesion test.